And welcome everybody to the Daily Space Weather and of the Smash News Network. Congratulations on realizing the channel exists. We've got new sunspots rising, massive filaments, coronal mass ejections, and lots more to cover, so let's get to it. Kicking off summer the right way with some fresh space weather activity. Huge plasma filament up there in the northeast. Hundreds of sunspots, pushing the 200 number is the sunspot number. Here's a close-up in GOES-R composite. That's ionized helium and ionized iron. Huge plasma filament there, just west of the Earth scale in the image. Let's briefly take a holistic view. Here is the northern hemisphere. How about the equatorial view? Again, that's hundreds of sunspots. We are pushing 200 sunspots. And there is the southern hemisphere, and huge crown prominence still hanging out down there in the south. You can see that in your lower left of your image there. And let's take a look at sunspots briefly. So a brief view of sunspots here for you. There is the SDO continuum yesterday plus today. Some large groups setting there in the southwest and in the northwest. Again, a large sunspot group rising in the northeast. At least one umbra already visible there. There is the colorized magnetogram for yesterday plus today. As space weather continues to ramp up as we get closer and closer to solar maximum, a thing that has not yet been achieved. Quick volcano rundown here for what's going on Croissant Earth. Yeah, the croissant-shaped Earth. Mount Mayon continues to erupt and produce a 9,000-foot ash plume in the Philippines. 14,000-foot ash plume over Semeru. That's East Java, Indonesia, by the way. Popocatépetl exploding, flight level 200 over central Mexico. It's a 20,000-foot ash plume. 19,000-foot ash plume over Nevado del Ruiz in Colombia. It's a flight level 190. Flight level 150 over Revenador in Ecuador. Cotopaxi exploding as well in that same nation, Ecuador. It's producing a 21,000-foot plume of volcanic ash. Also, Sabancaya, 23,000-foot ash plume over Peru. It's a flight level 230, a great reminder to not pole vault the caldera. Don't pole vault the caldera, folks. If you're going on a volcanic vacation, leave your vault pole at home. It could be unsafe. And we need the views on YouTube. So press like, subscribe, share, etc. And if you want to get further involved, why not pick up some sweet summer merch? Planning on going to a festival? Perhaps get an all-over print tote bag, or perhaps a pair of socks. I've got the socks. They're very comfy. And since our finest days lie ahead, please do not pole vault the caldera. Check out all the products we have. You could even get a do not pole vault the caldera mini skirt, sleeveless top, even a pet bowl. It does feature the YouTube channel and the homepage, smashomash.com. You can also find links below the video and on the homepage as well to the Smasho merch. We've also got an Amazon store, so check that out to see some shopping ideas for you there. It's amazon.com/shop/smashomash, and there is another paid promotion here as well from Hemp Lucid. So we've got a promo code. It's the promo code SMASHOMASH. Pretty easy to remember. The same thing as the channel. That'll save you 10% on checkout. So if you're shopping on hemplucid.com, don't forget to use the promo code SMASHOMASH to save 10%. On your checkout screen, there's also a link below this video, and you can find the Hemp Lucid link on our homepage as well. And welcome to the Neo Renaissance. Congratulations on realizing our channel exists. If you'd like to help support it, pick up some merch, some Hemp Lucid products, entering the promo code SMASHOMASH to save 10% on your checkout. Visit the Amazon shop, etc. More on channel promotion later in the video, and let's see what's been going on seismically. Earthquakes over the past 24 hours include the following list of 5 and higher magnitude quakes. South Sandwich Islands had a 5.2. Besides that, it's been quite calm over the past 24. I can tell just by a quick glance at the map. seismically calm conditions here. So only, it looks like, about 3 quakes of a 5+ magnitude here. There was a 5.1 at Japan early this morning at 1:24 Universal Time, and one at Tonga, which has been the most seismically active place in the world for the past week or so. Also a 5.2 there at 7:36 this morning. And let's get back to space. What's going on in space, you ask? Well, that's a thing. There's the past 24 hours in GOES R 171 angstroms. Again, massive sunspot region likely rising there in the northeast. We see at least one umbra already visible there, but at the moment, I suspect by the end of the video we may see more, so don't worry, we'll show you high-res imagery of that. So looking at additional space stuff, here comes some more space stats for you. The 10.7 centimeter radio flux has dipped. It is now at 174 solar flux units. Here the radio flux is depicted as a black line. That is the 1-year graph of the radio flux, having just popped out of a couple of different support levels there, getting above both 170 and 155, which is really the most important support level. As you can see, right around 155 here, there has been a lot of resistance both upward and downward at 155 solar flux units. Let us know in the comments if you think we'll get above 234 again on this solar cycle. I think we will, but we're interested to know what you think. Space Weather Enthusiast dashboard here. Okay, we're at 176. My mistake. 176 solar flux units is the current state of the solar radio flux. The 10.7 centimeter radio flux, also sometimes referred as the F107. And thanks for leaving comments, Robert and Mike. Now here we do see some geomagnetic unrest forecast late in the day on the 23rd. So that coincides with our CME impact that we forecasted. Although NOAA is not suggesting, NOAA's not saying why it is. So whether that's from a coronal hole or from a CME impact, a little bit of geomagnetic unrest expected late tomorrow, which would be Friday, June 23rd. That is right around when we would be expecting the CME impact to show up, though. If there was a glancing blow, it would happen around late in the day on the 23rd, early in the day on the 24th. As far as NASA's forecast for that CME, nope. NASA's forecasting it off to the east of Earth. So we'll just have to see what happens. We'll keep you posted on whether or not that CME did occur or not. Well, whether the CME did impact Earth or not. Here's the past 4 hours of Earth's magnetic moment from space. As we get into geomagnetism, this is basically what a proton sees in terms of magnetohydrodynamic pressure when it shows up at the Earth magnetic system. It's geomagnetically calm conditions here. That's the plasma pressure. Here is the magnetohydrodynamic pressure it is. This is magnetic flux density at the ground level. Earth's magnetic fields here, depicted in geospace delta B, changes to Earth's B field, the units of which are in nanotesla. You see some variations happening there. There have been some recent variations in the solar wind. The space weather modeling framework uses a lot of different variables, not just ground-based magnetometers. It also uses space-based magnetometers, electron flux, the solar wind parameters, magnetic field, the vertical component, and lots more data sets to obtain that 4 hours of Earth's magnetic moment from the ground. KP index currently at 2.67. Again, geomagnetically calm conditions, and let's take a look at the real-time solar wind, which we are expecting to switch to the ACE at any point here, because you see the last 24 hours, there's a yellow bar down there, which means error suspect. So for whatever reason, Probably because it's usually from things like low density, especially in here where the density is all the way down to, well, it doesn't get below 1 proton per cubic centimeter, but the current conditions are listed as, all right, I'll say the most recent conditions are about 400 kilometers a second for the solar wind. That's the velocity, solar wind density, about 3.3 protons per cubic centimeter. So expect to switch over to the ACE soon. That real-time solar wind looking pretty unremarkable for the past 24 hours. GOES magnetometers here, that's the past 3 days of their readings. Nothing too exciting going on there. You can expect to see those jump around if we do see a CME impact late tomorrow evening. And let's move to the heliospheric current sheet. So I feel like a broken record when I say this, but you see this blob of green right here? We are waiting for that to leave the north heliographic polar region. When it does, you can expect a further uptick in solar activity. It's not happened yet. That's our top view ecliptic plane field plot. There is a sector boundary crossing coming as well, and it may be delayed by another massive sunspot in the northeast. So it might look like this sector boundary crossing is going to show up earlier than it really does. I'm not convinced that it'll be here by tomorrow. At the moment, Earth remains in a South Pole current sheet depicted here in red. North Pole current sheet coming. It might be more like 2 days, or maybe even longer. Next, our line of sight field plot. Here's the sun's B field depicted in blue. The B field being the field that goes through the magnet, this magnet being the sun. Which brings us to coronal holes. Again, you've got hundreds of sunspots currently on the Earth-facing portion of the solar disk. So there is our line of sight coronal hole plot. And we do have some North Pole-oriented coronal holes there in the northeast. The southeast. We got the northeast as well. So more North Pole-oriented coronal holes here rotating in. And here's the view from SDO. That's 211 angstroms wavelength. And quite a bit of plasma motions happening over there, especially on the eastern and equatorial portion. So lots of stuff going on here. It's continuing to ramp up toward solar maximum. Next, we'll go back to sunspots. And we are pushing the 200 sunspots number. Like I said, look at all those named groups. You can expect, I believe, at least 2 more named groups here today. At least 2 more named sunspot groups there rising in the northeast. We'll show you high-res imagery of that toward the end of the video. Let's bring up the SDO intensity gram here. Once again, we're going to zoom in just to show any evolution that may have been going on in the past. Well, this is actually the past about 36 hours. That is yesterday plus today, the SDO continuum. So those are pretty stable. That is a lot of sunspots. And let's move to energetic particles and solar flares. So an M-class flare did happen while we created the show. There's the proton flux, no spikes in it, so no solar energetic particle events, despite an X-class flare having recently happened. And the most powerful flare of the past 24 hours was only a little weaker than the one yesterday. Very similar to the strongest flare yesterday. Occurred while we created the broadcast. And thanks for leaving comments, General Disturbance. So let's take a look at some of our favorite flare wavelengths. Here we've got 171 angstroms, and we've added 131 angstroms. The most active flaring region, I believe, is this one down here in the southeast. Again, look at these massive filaments rising here in the northeast. Let's drop the 171. Now we've got 94 plus 131 angstroms. And here's, I think, the most active portion here, this sunspot in the southeast. That is a great close-up for you regardless. You can see the size of some of those flaring activities, some of those flares larger than planet Earth. That is 94 plus 131 angstroms from the GOES-R. And that is a 24-hour time span. We'll zoom out briefly to show the 131 angstroms view by itself. A lot of different areas here that are potential large solar flare producers. We'll look at it a little more in depth here in a moment. And we're going to show you coronal mass ejections and so on. First, let's talk about some more stats. And let's actually break out the 94 angstroms wavelength. Yeah, 94 angstroms. So this is from SDO this time. Give that a minute to spool up. That is yesterday plus today from SDO, 94 angstroms. If you were banking on the sun shutting down, bank elsewhere, because those investments should be shorted. If you're banking on the sun shutting down, choose a different bank, because that is a bankrupt concept. Let's talk more about space. This is what's going on overhead in Lehigh Valley. I like to use skyandtelescope.org for my star chart at the moment. We've got Saturn and Jupiter up there, also Mercury rising ahead of the sun. I still think it's a great time to view the dusk sky, as you'll see Venus, Mars, and the Moon very close together near the ecliptic, just north of the ecliptic there. If you view the dusk sky tonight, that is the forecast for the sky over Lehigh Valley, Pennsylvania, again from skyandtelescope.org. Two of the three brightest objects there, visible at once. Next, a solar system forecast. A lot of people think the planets are going to kill you, so we show the forecast every day because people think that, you know, planets control the solar activity and things like this. I feel a little sad for them, but anyway, let's advance this 1 week to show you heavenly bodies, where those heavenly bodies will be located. There's where things will be on June 29th. We will have a gibbous waxing moon by that point in time. And by the way, happy summer. Yes, you're less than 1 day into summer by the time this video was produced. Happy summer. We did a couple of streams yesterday, 2 extended streams. Don't forget to press like and subscribe if you're new to the channel. Press the notification bell or whatever. Press that share button. Since our videos were conveniently demonetized yesterday for your viewing displeasure, for your viewing inconvenience, the videos were demonetized, which will make them harder for you to find. They will make them not recommended. And they will be buried in search, even if you search for them by name. So YouTube has idiotically disincentivized people to live stream, and we were expecting this video to be live streamed to YouTube. However, because of features and demonetization, we have been incentivized to not do that. So, sorry if you were looking for these videos to be live. They just aren't. It's not our fault. It is YouTube's fault. Next, we are also on Instagram. If you're interested in lots of fitness and lifestyle type posts, join us over there on Instagram. And more about social media here in a moment. And let's do coronagraphs. So here are the George Mason University coronagraphs. Multiple CMEs happening here. The likelihood of additional CMEs is 100%. You can expect to see CMEs continuing here. Coronal mass ejections, where the sun blasts sometimes billions of tons of material out of its atmosphere, known as the solar corona. That's what's happening there in the upper left. That's 100 frames from yesterday. Kicking off summer with CMEs. And here are 21 additional frames from today. That's all fine and good. Here's Soho, Lascaux, C2 and C3. We're going to show stereo A here in a moment. First, our custom coronagraphs. There's a 24-hour video showing the GOES R 195 angstroms along with Soho, Lascaux, C2 and C3. Now that CME looks like it is just off to the northwest there. It's kind of behind the northeast. It's kind of behind the northeastern limb where that activity happened. It's from that new active region. So, by the way, the most likely place to see an X-class flare is actually now in the northeast, because as that region rises, the likelihood of it producing a large... Sunspots like to make a big entrance and a big exit. They like to produce X-class flares when they're at the limb. It's just a little bit more likely than producing X-class flares in the center of the Earth-facing solar disk. So don't be surprised to see a big flare in the northeast. There is quite a lot of plasma activity happening up there, and many of us increasingly believe that coronal mass ejections cause the flares, not vice versa. Anyway, that's some heliophysics for you. Here's a further zoom in. It looks like we've got another comet there accelerating into the sun. And let's take a look at stereo A here as well, just to be complete in our coronagraph coverage. So these are what I would look for every day if I were trying to figure out if CMEs were going to strike Earth or not. Of course, our top priority is at this point completing a science publication suggesting a plausible mechanism that underlies the solar sunspot cycles. We deem that as more important than really even forecasting earthquakes, in that explaining the actual mechanism underlying the solar sunspot cycles will be the most important science publication in hundreds of years. So, but those are the coronagraphs, and we're going to move to filaments. So let's do filaments. El Teide, Spain, has a great hydrogen alpha ground-based solar telescope. That's great to view filaments. And let's talk about naming filaments. This one up here in the northeast, it looks a bit like a bass clef. So we're going to name that filament, and this is how you do it. You go over on Twitter. If you don't have an account, you create one. And then you put up a post like this. You click that button right there. That means to tweet. You wait 2 hours for Twitter's server to actually pop up a box. Twitter, the barely functional social media platform, like all the rest of them. Barely functional. You type in name that filament. And this will cause approximately 2 people to see the freaking tweet, because the shadow bans, deboosting, aka censorship, continue on all social media platforms. If you think free speech has been fixed by Elon Musk, snap out of your delusional world and enter into reality. Come on, man. Geddy Lee doesn't have a Twitter. Are you kidding me? You have got to be freaking kidding me, dude. That filament is named Geddy Lee regardless. Did I spell it wrong? I don't know. But this filament up here is the one we're talking about. That's how you name a filament. You got to do it on Twitter. You can't do it in the YouTube comments. You can't do it in the Twitch comments. Thanks, people, for leaving comments on Twitch. Thanks, everybody who follows over on Twitter. It's where the most action happens in terms of social media. It is still a pathetic soup of garbage and broken algorithms. Whoever is writing the code over there should quit their job and go work at 7-Eleven. It's truly pathetic. It's almost as pathetic as Meta. And by the way, if Elon Musk and Mark Zuckerberg have a cage fight, that is going to be also one of the most pathetic things in decades. Truly pathetic. What a joke. Two giant turds of social media, Elon Musk and Mark Zuckerberg. Giant turds. Here's the past couple of hours from Go's 18 SUVI. And look at this active region rising. This one is going to be quite good. There's a little bit of anticipation building here. Look at that active region up there in the northeast. It is berserk. And shout out to Eugene the Philosopher. Make sure you subscribe to his channel, Eugene the Philosopher. Yes, on YouTube. If you don't subscribe, then you're out of the tribe. You're off the island if you don't subscribe to Eugene the Philosopher. Anyway, while we're talking filaments, we'll also show the 304 angstroms wavelength from the GOES-R. We created these videos just for people like you. And of course, we've got some close zoom-ins of that northeastern limb. So that filament up there, you can see it's like a backwards S. It looks like a bass clef to me, so it's named the Geddy Lee filament. We're not abandoning the idea of naming filaments after living people. It's just that nobody sees the tweets or anything else because of the pathetic censorship on the platform. So anyway, that's what's going on. And we've come full circle with our solar images. That is one towering filament indeed, ahead of a new massive active series of regions. Probably a series of multiple large sunspots. Anyway, it's time for bonus features. So we're starting things out with the satellite's community dashboard, where we do see some charging hazards here. Some minor surface charging hazards here moving into the central Pacific Ocean. That's low energy electrons on the outsides of spacecraft. Don't expect any major communications breakdowns as a result of those minor surface charging hazards. Minor space weather there. Electron flux here looking like it's coming down a little bit from yesterday. I think we might have a break in the electron flux here. We've been having pretty high levels here for quite a few days. We're expecting that to subside soon. I think NOAA agrees here. First, the 1-year graph to put it in context. You can see a little bit of a dip here. We're just in the moderate range of the relativistic electrons. Those are measured at the F layer of the ionosphere. And there's the forecast expecting a gradual dip. Keep in mind, if we do see a CME impact tomorrow night, you can expect a more sudden dip. Expect this to be way down. Expect this to be way down here for Saturday if that CME does impact. Again, that's measured at the F layer of the ionosphere. Feel free to pause the video if you're not familiar with the data depicted here and distances in kilometers and so on. Here is the ionosphere in vibrational frequency. And yes, thanks, general disturbance. Facts are very controversial. And of course, that started back in something like 2015. Did you know I stopped using Google as a search engine in about 2012? Yeah. When I realized it doesn't work properly as a search engine, I stopped using it immediately because it doesn't work. It didn't work in 2012, and it's only gotten worse. Anyway, that's the ionosphere, and we do see some significant low-frequency anomalies, at least. That's the way to kick off summer there, with a puffed-up ionosphere. Here is the anomaly in megahertz from a 30-day median. And here at the Smash News Network, least busted name in news, we're fans of one thing. Yeah, one thing. Not you, not your favorite band, not your favorite political person or tech executive. We're not even a fan of your YouTube channel. We're a fan of one thing: facts. Or you could say the truth. Or you could say accurate depictions of reality. That's what I'm a fan of. Because to be a fan is to be a fanatic. If you're wondering which hill to die on, the answer is none of them. Don't shatter your credibility by being a hack fraud. Anyway, there's the latest image. That's 12:15 Universal Time Ionogram. And there's the 12:15 Universal Time Anomalygram. Total electron content is free electrons to about 12,500 miles of altitude. Feel free to pause the video on this frame if you are unfamiliar with distances to those things in miles. Here is the total electron content. It'll show you the most likely place to see GPS errors. Yeah, the most likely places to see GPS errors caused by signal refraction by those free electrons, ions. They'll refract your signal, and we're having some major GPS errors happening here in places like the Southern Indian Ocean, the Southern Ocean. Out of place a little bit there during certain parts of that model run. Right in here, you'll see huge electron anomalies there and over Antarctica, the Southern Ocean, and the Southern Indian Ocean. We'll let her play through one more time, and then we'll show the North American anomaly. So that's what's going on for total electron content for the planet view. Here is the North American 10-day, that's anomaly from the 10-day average. Total electron content is literally depicting a count of free electrons. Where you see red, you're seeing high electron counts, and when you see blue, you're seeing low electron counts. So that is the anomaly from the 10-day average over North America for total electron content. And let's break out the latest intensitygram and magnetogram. So check it out. It looks like two new groups there. Nope, it's only one group in an active region. So this larger plage here, large plage, not to be confused with large marge. That large plage is not yet a sunspot, but the area to its north is. So that's at least one new sunspot group. Oh, here's another one. Check it out. There are two new Umbra. There's another Beta Gamma class sunspot group. And I think this is another one that doesn't have a name yet, so that's three new name groups. Now we're expecting three new name groups before tomorrow's video comes out. So, yeah. Oh my God, folks, stop the presses. It's summertime and the sun is shutting down if you're living in a completely delusional cult. If you are in a delusional cult, you think that is a grand solar minimum. Good God. Hey, Talc, come out of your hole. Come out of your hole that you've been occupying with Al Gore and enter into reality. Diamond, stop making out with Al Gore, watch our channel, and get your head out of your posterior. Now let's talk about correct forecasts. We do them constantly on the channel. And here's another example of correct forecasts. How do we do it? By understanding the physics. Yeah, you just understand the physics, and then you'll be able to forecast. If you don't understand the physics, you can't forecast. It's a very simple formula. And what we're looking at here are two tropical lows here in the subtropical Atlantic Ocean. And this one here, guess what? It's turning out to be a giant dud. Why? Because it's all encased in Saharan dust. Look at all this yellow. That's all Saharan dust. That is the DUX, which is the optical thickness 550 nanometers. In other words, it's dust from the Sahara, and it's been tamping down those systems along with wind shear caused by a high-pressure dome to the north. So, in other words, it did exactly what I said it would do. Basically be a complete dud and just provide a little bit of gentle rainstorms to the Leeward and Caribbean islands. So that's our nullschool.net imagery. I mean, if I switch to air pressure, you'll be completely uninspired by this. The pressure is at like 1,000. 1,000 hectopascals. That is not what you would call a serious hurricane type system. I mean, the pressure is like probably higher than the pressure up here in the North Atlantic. Look at the Southern Ocean's low pressure systems. That is yowzers. Look at that. An Antarctic low pressure system stretching all the way into the Southern Pacific Ocean. Anyway, let's move on to our standard issue wind maps. There is the surface wind scenario for the eastern world. Here is the jet stream scenario for the east. Still blowing backwards over the central Indian Ocean. Here are the jet streams of the central world. Stagnant jet stream over northern Africa. Almost no jet stream to speak of. Surface winds depicted here. A bunch of strong lows there in the Southern Ocean. Surface winds of the west depicted here. And these are the jet streams. Jet stream all over the place in the U.S. Once again, we have a divergence over the central part of the country. And then we have like a backward jet stream here over the Great Lakes. Check it out, the jet stream here blowing backwards over Huron and northern Lake Michigan. It's a little jet stream eddy there. And if you think that is evidence that Earth's poles are flipping, you still don't understand physics. So check it out now. It's our windy.com view, and we're showing some satellite imagery of these two tropical lows. And you see all those parallel lines there? Guess what those aren't? Chemtrails. Guess what those aren't? Geoengineering. Guess what those aren't? HAARP. Those are streamers of wind and water currents that are attempting to reach static equilibrium between this relatively weak low pressure and the higher pressure around it. Because air is getting pulled into this system. That's what a low pressure does. You can actually see an inflow right here. Because low pressures suck and high pressures blow. That's windy.com's satellite imagery, by the way. You can get the free mobile app if you like. From guess where? Windy.com. Here is clouds and fog over the Americas. More controversial facts. Oh my God. Sorry about all the facts, folks. Look at those huge heat sinks there. They're called oceans. The Atlantic and Pacific and Caribbean Sea and the Gulf of Mexico and the Sargasso Sea, and all of these areas are massive heat sinks. Yeah, water. It stores a lot of heat. Did you know that only less than 1% of Earth's surface thermal capacity lies in the atmosphere, and the other 99+% lies in the water on the surface of the planet? Yeah. Because air heats up and cools down quickly, and water requires a lot of energy for that. And here's your U.S. weather forecast. A bunch of flooding forecasts for the southeastern U.S., as well as some, it looks like, what the heck is that? Excessive heat watch. Excessive heat watch is there. Anyway, a bunch of warnings if your location is lit. Click your location on weather.gov. Those are too many counties for us to cover. Let's look at some forecasts. So first of all, here's the tropical forecast. There's the tropical forecast, and I said, what, 4 days ago, that this low up here was going to be a complete dud? Well, there it is, fizzling out as it moves south of Puerto Rico. This other system is going to also weaken. It is inundated with Saharan dust and wind shear. That does not strengthen systems. Understand the physics. You'll be able to forecast your weather, just like I just did for the tropical Atlantic Ocean. Here's a lower 48 forecast for jet streams. You're wondering if jet streams are going to get more coherent? Well, in about 3 days, they'll start to refill here. You've got this one strong jet here moving across into Nebraska and Iowa in about 72 hours. By the way, this is a 72-hour GFS pressure and precipitation forecast, and this is the GFS 72-hour 250 millibar wind speed forecast. In other words, the jet streams, based on the same weather model. Here is your total accumulated precipitation forecast in inches based on the same 72-hour GFS model. Heaviest rains coming will actually be in Nebraska, South Dakota, North Dakota, and Minnesota, where they're expecting like 4 inches of rain. Also Montana expecting heavy rains. Also Georgia, Florida, South Carolina, North Carolina, and Virginia expecting quite a bit of inundation, even some heavy rains in Pennsylvania. It looks like New Jersey's drought woes will start to subside also in the coming 72 hours. That's the way to kick off summer, with droughts ending. I like to see that. Sorry if you were hoping we'd forecast some disasters. That's generally going to be a good thing. And here's the way it'll play out with your pressure and precipitation map. That's your GFS pressure and precipitation map for the next 72 hours. And let's move on. We don't want this video to be too lengthy. Here's your lightning mapper. That's the past about 10 hours. And once again, the Gulf states and Texas getting heavily hit with lightning. Also Colorado. Maybe some of that hot air causing upwellings and pressure gradients and static electricity and plasma discharges. And that's what lightning is largely doing. And next, your real-time lightning map. Do we have any terrestrial strikes? Just in the Gulf and near the Kansas-Colorado border. Next time you hear thunder, check it out. Shout out to Wot Artie Noobs. Yeah, W-O-T Artie Noobs. He checked it out last time he heard thunder, and then he forecasted thunder like a horror movie villain. You gotta love that. Who doesn't want to look like a horror movie villain? Frighten the natives. Convince them that you're Zeus or perhaps Thor by forecasting lightning yourself with lightningmaps.org. If you want to support the channel, consider becoming a member of the Smash Team. The official subscription services site is smashomash.com/SmashTeam. It's almost like Patreon, only good. And it's our own site, which we built ourselves. Shout out to Smash staff. Give her a raise by becoming a member of the Smash Team. If you want additional content, join at the gold or silver level. There's even a bronze level. And we send out email alerts for things like tsunamis and space weather, even to the bronze level. smashomash.com/SmashTeam. These videos were brought to you in part by our Gold and Silver Smash Team members, so perhaps you should thank them for the continuation of the existence of these videos. Smashomash.com is the official homepage. And welcome to the Neo-Renaissance, as there are some major paradigm shifts about to happen in the realm of cosmology and also in the realm of human technology. We've been forecasting it for a few years, and it's starting to become more and more evident what changes are going to happen. We tell our Gold Smash Team members about this before anybody else. And let's close this thing out with Doppler radar for the full 50 states. But we'll be focusing on the lower 48. Quite a bit of moisture here in the eastern part of the U.S. Get your bike rides in before the roads are wet. Here is clouds and fog. You can see that low pressure is currently centered right around southeastern Tennessee. It'll be even more obvious on this image. Once again, understand the physics. You'll be able to forecast your own weather. And if your Doppler is not giving you the full picture, try the water vapor map. If you're aware of how the jet stream is blowing and where the cold versus warm air is and where the moist versus dry air are, you'll be able to forecast your weather. Here's a recap. U.S. Doppler radar. That shows vertical motion in the air column. Clouds and fog are depicted by 3.9 micrometer infrared radiation. It shows clouds and fog even at nighttime, considering it's dark in Texas yet. And here is water vapor. And thanks for tuning into the Smash News Network, least busted name of news. I'm headed back to the bunker because I'm trying to figure out if an inactive sun is scary or if an active sun is scary. Anyway, we hope we figure it out. We'll let you know perhaps on YouTube if you're able to find the content. In the meantime, bye. I'm going back to the bunker. Whoa!